Hey, have you ever wondered why your computer completely forgets everything when you turn it off, but your phone remembers all your photos? Well, it all comes down to something called primary memory. And if you're getting ready for your GCSE computer science exam, this is going to be everything you need for section 1.2.1, all broken down nice and simple. So here's our game plan. First, we're going to dig into why computers even need memory in the first place. Then we'll get to know the two big players. That's RAM and ROM. After that, we'll check out the secret speed booster, cache, and a really clever backup plan called virtual memory. And to finish it all off, we'll wrap up with a quick revision checklist to make sure all these key facts stick. Okay, so let's start right at the beginning. Why even have memory at all? Well, the computer's brain, the CPU, it has a bit of a problem. It's unbelievably fast, but it has practically no memory of its own. It desperately needs a place to hold all the information it's working on, right now. You know that awful feeling, right? When the power cuts out and you lose an hour of work? Well, that's not actually a bug. It's a huge clue that tells us exactly how this kind of memory is supposed to work. Okay, let's use an analogy. Imagine the CPU is a master chef, just flying around the kitchen at lightning speed. Now, this chef can't possibly hold all the ingredients, the pots, the pans, and the recipe book all at once. It's just not possible. They need a kitchen counter, a temporary workspace to lay out everything for the meal they are cooking right this second. And that, right there, is exactly what primary memory is for a computer. Right, so on this kitchen counter, there are actually two totally different kinds of workspaces the chef uses. We call them RAM and ROM. And even though they both hold information, trust me, their jobs could not be more different. So RAM is that main kitchen counter we were talking about. It's where the chef, our CPU, puts the operating system, all the apps you're running, and the data for those apps. It's big, it's fast, and it is where all the action is happening. ROM, on the other hand, well, that's more like a small, unchangeable instruction manual that's physically built right into the oven. It has the absolute first, most essential instructions the computer needs just to turn on and get going, a process called the bootstrap. And the crucial part, it doesn't forget when the power is turned off. Now, this is the core difference you absolutely have to get for the exam. RAM is volatile. Think of it like a whiteboard. As soon as the power goes off, it gets wiped clean. You can read from it and you can write to it. ROM, however, is non-volatile. It's like a printed book. It keeps all its information even with no power, but you can't change what's written inside. That's why it's called read-only. Okay, so we've established RAM is fast, but modern CPUs, they are insanely fast. So fast that sometimes even waiting for RAM can slow them down. To get around this, computers have a secret weapon, an even faster, much smaller type of memory called cache. Let's go back to our chef. If RAM is the big kitchen counter, then cache is like a tiny little spice rack kept right next to the stove. It holds only the most frequently used ingredients, or in our case, data and instructions, so the chef doesn't even have to reach across the counter. It's all about that instant access. And the difference in size here is massive. Your computer probably has gigabytes of RAM, but only a few megabytes of cache. So why so little? Well, it's because this memory is incredibly fast and really, really expensive. It's not meant for storing all your files. It's a super specialized, high-performance tool just for the CPU's most urgent jobs. The secret to cache's incredible speed is actually pretty simple. Location, location, location. It's built physically closer to the CPU. Sometimes it's even on the very same piece of silicon. This tiny, tiny distance means data can be fetched almost instantly, completely cutting out the travel time delay of having to go all the way out to the main RAM. That's what gives it such low latency. But what happens when our chef gets a little too ambitious and tries to cook like a dozen different dishes at once? Well, the kitchen counter, our RAM, gets completely full. But you can't just stop, right? So the computer's operating system has this very clever trick up its sleeve to create more space, and it's called virtual memory. So how does it solve this problem of a super cluttered counter? Well, it uses a little bit of digital magic to basically extend its workspace. When that kitchen counter gets way too crowded, the chef temporarily moves the ingredients they aren't using right this second over to a nearby pantry. In the computer's world, that pantry is your hard drive or your SSD. This frees up space on the counter for the most important task at hand. Now, this swapping process is something the exam board loves to ask about, so listen up. Data that's not being used gets moved from that fast RAM to your much slower hard drive, which frees up precious space. Then, when that data is needed again, it gets swapped back. It's a fantastic solution that stops your computer from just crashing, but there is a catch. All this swapping back and forth takes time, and that's why your computer can feel so sluggish when you have way too many things open at once. All right, let's pull everything we've talked about together. To really nail this topic for your exam, you need to be able to compare these different types of memory side by side. So here it is. The crucial point is understanding how these four memory types all relate to each other. Just look at the patterns here. Cache is the fastest, but it's the smallest. Virtual memory is the slowest, but it's by far the largest. RAM is your volatile main workspace, and ROM is that non-volatile startup manual. Honestly, this is your ultimate revision slide for primary storage. And there you have it. That's everything you need for this part of your exam. But, the story doesn't stop here. As processors get even faster and things like AI demand more and more power, this memory bottleneck is one of the biggest challenges in all of computing. The tricks we've talked about today are brilliant, but they're already being pushed to their absolute limits. So the real question is, what's going to be the next big idea in memory that unlocks the future of technology?